Hey y'all, we've already talked about volume because volume is length times width times height. We've also already talked about rectangular area. Rectangular area is length times width or base times height, whichever one you want to look at. But now we're going to talk about surface area. Surface area. Surface area is the total area of all of the surfaces of a three-dimensional figure, like a cube or a rectangular prism or triangular prism or whatever three-dimensional thing you've got. Surface area can be calculated using a net. But what are we talking about when we say that? We're not talking about the thing that hangs off the basketball goal. We're not talking about something you catch fish with. We are not even talking about that stuff that you gotta hook up to your PlayStation or your Xbox so that you can play Fortnite against your friends or 2K or whatever it is you do. We're not talking about streaming services. When we say a net in math class, this is what we're talking about. Boom! Here I am. I've got a three-dimensional figure. So, if we take a three-dimensional figure and we cut the sides along the edges so that we can unfold it and have a flattened out shape. That is a net. Ta-da! There it is, represented in two-dimensional shapes for the three-dimensional figure. If you were to fold it along those dotted lines, you would get the box all over again. That's a net. But if that's a net, how can I put it to use? Well, in order to put it to use, you need numbers. And where better to go to get numbers than math class? I've got numbers all over the place. Let me put the actual numbers on here. Shazam! Look at that. It's only got 3 numbers, but all those lines. We can figure this out. So, let's look at this. The 10, that's the long side of the box. And how many lines or edges of that box have that same measurement? 1, 2, 3, 4, 5. All 5 of those have the measurement of 10. But Mr. Starling, there's 6 sides to a box. That's only 5 edges that are labeled 10. That's right, because those 5 edges only make up 4 sides. We've still got the other 2 sides at the ends up here and down there. Those are our other 2 sides. The total number of edges on a box is, well,
5, 6, 7, 8, 9.
No. That is untrue, and here's why. Because when you fold those together, some of those edges become the same edge. The 10 down there at the bottom will wrap all the way around and be the 10 up here at the top. This 10, that 10. So, don't worry about counting which side is going to be which side of the box right now. Focus on making sure that you've got all of the sides of the net represented, all of the measurements of those sides, and can find the area. So, what about the other sides? This 3, what does it go to? I'm glad you asked. That 3 goes to both of those lines. The 3 is this line and that line, because those lines have to have the same measurement, because when you fold it, those 2 lines will touch. What other lines measure 3? Those lines. Those lines are all the lines that are a measurement of 3. This is, by the way, in inches. How many lines have we got that measure 7? 1, 2, 3, 4. I see 4, but there's still more. Let's start by labeling those 4. Okay, so those lines are obviously 7s because it's just 7s all the way down. We're just following what's there. 7 at the top, 7 at the bottom, 7s in between. It's like a 7 sandwich. But we don't have all of our lines that are 7s labeled yet. In fact, if you look it's kind of the only lines that are left. Those lines over there, those are 7s as well. Why are those 7s? Because those 7s, when we fold this up, will wrap around, and that side will touch this side. Pretty cool, I guess. Now, what can we do with this, though? Well, we can find surface area. Yay! Everybody likes surface area, right? Well, if I'm going to find surface area, I'm going to need to remember that the formula for the area of a rectangle is length times width or base times height. How many rectangles do I have that are 10 by 3? There are only 2 rectangles that are 10 by 3. If you folded this box up like this, the 10 by 3 sides would be the front here where these words are, and the back here where the rest of the chicken's hair is. Chickens have hair, right? So let's calculate the area of a 10 by 3 rectangle. Length times width, 10 times 3, 30. There we are. Now, how many of those do we have? 2. What other rectangles have we got? Well, how about the 7 by 3 rectangles? Go ahead and get all our 3's out of the way. Wouldn't you know it? We've got 2 rectangles. One over here, one up there. They're both 7 times 3, and 7 by 3 is 21. Bloop, bloop. But what about the other rectangles? There's 2 here that are kind of plain still. Well, I'm not going to color in those other 2 and make cool lines on them or something, turn them plaid, I don't know. It just seems like a lot of drawing. We've got the 2 rectangles that are still plain. Those rectangles are our 10 by 7s. They would be the chicken side of the box and the bottom of the box. Our 7 by 3s were the 2 ends. So when we calculate the chicken side and the other than the chicken side, the bottom of the box, we multiply 10 by 7. Wouldn't you know it? 10 times 7 is 70. And we've got 2 rectangles that are just like that. So 70 and 70, 2 70s. But what do we do with all this? Well, we did say that surface area is the total area of all of the sides of a 3-dimensional figure. Let's get the surface area of the chicken box. So no diggity, we can just add it up and say 30 plus 30 plus 21 plus 21 plus 70 plus 70 and have our surface area, since that's the area of each one of the sides. Well, what we get is that that's 242 square inches. So what would our formula look like if we were to do a formula for the surface area of a rectangle? So what would a formula look like if we were going to have a formula for the surface area of a rectangular prism? Well, for starters, we'd have length times width, and we'd have that twice. So why not just go ahead and call it 2 times length times width? Yeah, kind of like that. What else have we got? We then multiplied our height times our width. And we could say that that is 2 times the height times the width, since we did it twice. Lastly, we multiplied our height and our length. Okay, so we've got our length times height twice, or our 2 length and height. But we still had to go through and add all that up. So let's see what that could look like. It could look a lot like that. 2 times length times width, plus 2 times height times width, plus 2 times length times height. That works pretty good. But what if we wanted to factor out our 2's? Yeah, we could make it look like that. 2 times the quantity length times width, plus height times width, plus length times height. You can use either of those formulas, whatever's going to make the most sense for you. I choose to keep the parentheses on the length width, length height, even though it doesn't make a mathematical difference, because it helps me remember that each one of those is a group for a different side pair for the rectangles. Okay, so what about one more example, just for kicks? Here we have the Nakatomi Towers. Hans Gruber, that's him up there, wants to wrap the entire tower in rescue puppy. Wrapping paper. We need the total surface area of the building, including the bottom, because he's that crazy. So, what do we do to find our surface area? We remember our formula, which looks like this. Ta-da! Our formula, we've got length times width, and length times height. We're going to multiply each number times the other two numbers. Does it matter which one's which? No. We could have the same building laying on its side, knocked over in a storm, and it would still have the same surface area. So let's put some numbers in the formula and make it happen. This building is approximately 490 feet tall and about 980 feet by 980 feet. Let's plug those in. So there we have it. It's 2 times the quantity, 980 times 980 plus 490 times 980 plus 980 times 490. One of those is the length, one of those is the width. 980 and 980, it happens to be the same. Then we've got the 490. The 490 was our height. Any way we put the numbers around, it still would come out the same though. Let's work through it. Okay, so 980 times 980. Good time for a calculator. I used mine. 9600,400. Okay, so I plugged mine into a calculator, did you? 980 times 980 came out to 960,400. So I jump in with my calculator, and since the last two pairs are the same, 980 times the 490 and the other 980 times the same 490, I went ahead and wrote it twice. So now that I've got all my numbers multiplied, I just have to add it up. Let's go ahead and do that in the calculator too. That's cool. The 480,200 plus 480,200 came out to 960,400. Now we've got two of those, and then we're going to multiply by 2. Mr. Calculator says that when you add those two numbers together, you get 1,920,800. Wow. So now we multiply that by 2, and what do we get? What you get is 3,841,600 square feet. And remember, if you've got square feet, it's going to be hard buying shoes. Well, I decided to check the giant online retailer and see what they had in terms of wrapping paper that had the puppies that do the fire and police and rescue stuff. And they had rolls of wrapping paper that were 70 square feet per roll. If we divide that into the number of square feet that we had for the building, we get that it's going to be 54,880 rolls of wrapping paper. Now, they're kind of proud of this wrapping paper. It was $24 a roll. Multiply that 54,880 by 20, and it's going to cost Hans Gruber $1,317,120 to wrap the entire Nakatomi Tower in the wrapping paper. My question for you is, do you understand how to do surface area? Because that's probably more important than choosing an affordable wrapping paper if you're going to be an international terrorist on Christmas.